BISP Solutions. So now our today's session is on multi-layer perceptron, right? Yesterday we saw the perceptron, right, in which we have seen the loan amount related data, right? Multi-layer perceptron. So now let me give you first the practical example of daily life, right? Then it will become more easier to connect with this what is multi-layer perceptron. For example, let me open this paint shop, right? Now suppose previously what happens if I was asked to take the interview of the candidate, right? Candidate 1, similarly candidate 2, candidate 3, right? Now what I in last few years how the interview process was taken place, like question and answer, right? Q&A. Similarly here also Q&A, right? And another is here also Q&A. Let's take. Now those who could reply, they are passed to they are qualified to the next round, and those who could not reply, they are rejected. So this was all about the process, right? For example, let me take this. If he could reply, he is passed. If he could not reply, then he is disqualified, and if he could reply, that is passed. So that's the simple process of interview. But later on, today, in maximum fields, in maximum companies, the process is a little different. For example, same thing we are taking again, same thing we are taking Q&A, question answer, right? Let's take this here. Now what will happen, let me take this, right? We will take from here. Okay, now just a second. Yes, that's fine. Okay, now suppose today also the scenario has changed. For example, again I am having 3 candidates. I have asked question and answer to them, okay, and 3 of them, they are able to reply the answer. But one more thing is there, that I will check now, since these candidates will be deployed on project, so I will check the communication skills also. That means one more hurdle, right? So I will check whether they are having good communication skills or not, because replying answer is a different thing. Again one more what we say, the hurdle, again one more filter process I have used, that is testing the communication skills. That's it. Right? Then again one more hurdle. For example, suppose if they could reply them, then again I will check how the attitude of each of the candidate, because in company require the candidate who is humble in nature, who is soft spoken. So again attitude testing, whether they will have a they will go with the long run with us or not. So these are called multiple hurdles, so that best of the best candidate will be taken out. Same thing. Now this was just an example. Now see here, now multi-layer, let's take perceptron. After that, what is deep neural network? A deep neural network is a type of artificial neural networks with multiple hidden layers. Now these hidden layers, that what I was talking about, just taking the question, asking the question and taking answer, and on the basis of that selection, that was old procedure. Now we have taken different filtration process. We use different filtration process to get the best of the best candidate among the bunch of candidates. Same thing here. The deep neural network, the multi-layer perceptron, what it does, it creates different layers, so that the best of the best decision will be taken. Now look at this. A multi-layer perceptron neural network belongs to the feed forward neural network. It is an artificial neural network in which all nodes are internally connected with each nodes of different layer, right? This is the input layer, then this is the another hidden layer. So what this multi-layer perceptron does, it again generates the solution, and based on that, finally the one answer will be taken out, that okay, this is either yes or no. So this is the final answer, that is either yes or no. I recommend you to watch my previous video if you have not watched that yesterday's session, right? So here the same thing is done, but here I have shown you with real life example that based on the requirement, so best of the best candidate should be selected. So we have applied different filtration process. So this is the human brain that we have done all these things, but how the machine will do, that's a different thing. Now see here, in this multi-layers, it's a multi-layers perceptron, and it is a non-linear, right? So you can see here, this is linear perceptron, and that is a combination of these both two, so that all green and accurate answers or accurate decisions will be taken by this perceptron, multi-layer perceptron. If you could see here, if we both mix, so finally whatever the solution will be taken out, that will be more accurate. If you see this yellow image and if you see this blue image, they are not accurate at all, right? So to make them accurate, so what we have done now, if you see here, this is one more third layer, right? So in this way, finally the best decisions are taken like this way. Let me explain you. I will explain you with the practical also, right? Now see here what we are going to cover in this model workflow. Okay, that's fine. Now here again the same thing, get data ready, turn it into tensors. So first of all we have to get the data, then we have to convert it into the numerical value, as yesterday we have done. Again we will do this in our practical. Then first of all what we do here, let me show you this. First of all we get the data, and if you see here, train test. Now again the train test process, same thing is here. Suppose if a human brain can take decisions because we are human, but for machine language we use train test technique, right? It's a function that is train test. Then we standardize the formula, after that we convert the data to the tensors. So same thing we are going to do this. If I show you this, already we have discussed in our yesterday previous session, right? So training the model, how the model is trained, every time the epochs are running. Epochs means it's an iteration, step by step they run and refine the final output. Refining the final output. Suppose let's take again one simple example. If I one candidate is sitting in front of me, so first of all I will take the question and answer, right? If he replied okay, that's fine, then I will try to judge that what type of whether he is good in communication skills or not. Okay, then if he is good, then I will try another method. I will check that how the way he is talking and what type of ambitions he is having. If he is more ultra ambitious, then there is a chance that he might abscond in the middle. So these are the different what we say neurals, that I am taking the support of different decisions, small decisions, and based on that I will take the final decision whether to recruit that person candidate or not, right? So this is we are doing with our experience. Same thing is done with the multi-layer perceptron, right? So in single layer perceptron, whatever we studied yesterday, in that what happened, only basis of that, on the basis of that, that's a linear single layer perceptron. This is multi-layer, means hidden layers are created for the target of decision making, right? So that is why this is called multi-layer perceptron. Okay, so this is clear to you. Now let's have some technical practical also, right? Now see here, I am having the data of employee attrition. For example, let's take an example. If I show you multi-layer perceptron, here is okay, no problem. I am having the employee attrition, right? This is the data. Look at this. I am having an Excel sheet of a company, right? I am having an Excel sheet of the company, and then that company is having some data, like these are the genders, these are the years, how many years that worked, and what is the attrition percentage, right? So attrition rate, how many of them they left the company, and how much they serve to the company. So all these data that I am having, this is of a company data, right? Now let me take one new IPyNup file, multi-layer perceptron. Let me rename this multi-layer perceptron. This is a simple untitled, okay, multi-layer. Multi-layer perceptron, right? And then I will rename it. Okay, so this is called multi-layer perceptron. Now for this multi-layer perceptron, now the main difference between this yesterday's perceptron and today's perceptron is the creation of the hidden layers in the middle, from the point where we are giving the inputs and the point where we are taking the decisions. So the middle, whatever the middle space is there, we are applying different hidden layers. We are creating different hidden layers on the basis of which the decisions are taken, right? Okay, so let's start. I have already copied it into a notepad file so that it will be much easier for you to understand. So see here, first of all, what we have done, we have to bring all the necessary what we say, the libraries, right? So import torch.nn. nn is the main library that will use. Torch.optim is the library used for optimization. Okay, now numpy is the library that is used for numerical calculation. Matplotlib is for plotting the data. Scikit-learn for train, test, split, because training and testing, right? Then sklearn, pre-processing, and then decomposition, that is the PCA. How this PCA is used, at the end of this session you will come to know. Pandas as PD. Panda is the most popular library. So now I am going to hit the enter button. Let's wait. Okay, let's wait here. Yeah, now it is still working, so let the libraries come here and then we will work. Right now I will have to read the Excel sheet. So here is the Excel sheet data. Now data equal to pd dot read csv employee attrition underscore bootcamp dot csv, right? So now look at this, there are total 1000 rows and 17 columns. Now in this 17 columns there are different data of different fields, right? For example, number of promotion, this person how many number of promotions. So these are different criteria, right? And whether he stayed or whether he left, everything is written here. Now Now again, here you are seeing the alphabetical value. Now alphabetical value, we do not want this alphabetical value, because this perceptron and the what we say the prediction techniques, they work on numerical values. So our next task is to remove all the alphabetical value, right, and replace it with numerical values. So that, suppose data gender. Now data gender dot map male colon 1, female colon 0, job role, whatever the job role, education 0, finance 1, healthcare 2, job satisfaction, so high, low, medium, very high. So in this way we have mapped each and everything with 0, 1, 2, 3, 4 correspondingly. Now if I show you, look at this attrition. So 1 means stayed and 0 means left, right, and everything is changed here, you can see. So the prediction techniques, the perceptron, all these works on numerical values only, right? So we need to change the alphabetical values. Now what happened here? Next task is to split the data. Now see here, yesterday we discussed two types of variables are there, data are there, that is dependent data and the independent data. Independent data is the data that you don't have any access on, that you can't do anything on that. For example, if person's age is given, whatever his background is given, so these are the independent data, and based on that future data, the prediction data that we have to do, so that is called the dependent data. So again we have to split the data. So attrition means whether he will switch to another company or whether he will not switch, so that is called the dependent variable. And here is the independent, all remaining all is the independent variable. Suppose if I show you x, so x is total 16. Now x value, x dot shape, right, x dot shape, look at this, 1000 rows and 16 are the columns, right? Similarly y, if I show you this y and y dot shape, suppose if I enter and y dot shape, look at this, only one column is there, right? That is the attrition, right? So that is called the one column. Now what we do next, let's see this. I have already shown you this, right? Shape means how many columns that they are having. Okay, now we are having the shape, we have given the value of numerical now, and also we have split the data. So first of all, what we have done, first of all let's write here also, right? If I do this, replace numeric data, that is the one thing, then splitting the data, okay, so that is the another thing, and then now train test, right? Train test, converting to train test. Now here you can see x train, x test, y train, y test. That means x is the different variable, y is different variable. So x train, x test, that means whatever the 80%, 70% of those data. So we are having 1000 records, look at this, 1000 rows. So the 70% of that is 700, right, with 16 rows, and remaining 300 rows for X test with 16 columns. Similarly 700 with one column, that is the X train, and Y train, and Y test means remaining 300 comma one column. So X test size, that is 3, that means 30%. so 70/30, here we are taking 70/30, right? Random state 42 means the data should not shuffle, right? So this is all about converting top train test, converting to train test. Okay, now here one standardized feature is there. Now see here, and here standardized feature means fit to transform. The data we have extracted, the data we have separated, everything is fine. Now we are going to fit to transform, right? Fit the data in that particular train test function, right? So we have done this also. Now what next? Convert Pytorch tensor. Yes, that is the next task, converting to Pytorch tensor. So tensor, again I have shown you in the Excel sheet. Here you can see the tensor. Tensor means it's a matrix, but it understands only matrix only. So that is why converting the images also into matrix. So whatever we do in this Pytorch, tensors are created, right? So now I have created the tensors also. Okay, now let's move ahead. Define MLP model, machine layer, multi-layer perceptron, right? Let's paste this. Now this is a little trick here. Now look at this, define MLP layer model, right? Multi-layer perceptron model. So here you see multi-layer and input size is 16, that means all the 16 columns, right? And here we have applied the ReLU function. Then similarly in this FC2 output size is, here is the output size, right? Okay, so now here sigmoid function is used for the calculation, right? Then if you see here forward function, this is also used. Now so far it was completely predefined. Now model MLP input size equal to input dimension output size equal to 1, right? And here BC cross means binary cross entropy loss. We are calculating the loss of binary cross entropy loss, right? This is also standard process here. Then optimizer equal to optim dot Adam model parameter, right? Now let me enter this. Okay, now see here, now you can see here MLP class is created. Now I have to train the model here. So far what we were doing, we were just training the creating the model, right? Now epochs 100, it is defined. It is up to us that how many times the iterations needs to run. And then here you will see the this is the formula written here. Now if I look at this epoch is running, and here you have whatever you have given the percentage or whatever the calculations, same thing written here only, right? Then what we are going to do here, evaluate model in trained data, because we have see, first of all we have to create the epochs here, right? Epochs means it's iteration. After that, what we need to do, we need to create train the model. For this we need to calculate the epochs. Now with torch.no gradient function, right, we have to evaluate in the train data. So train and test, train means 70% of data, so y underscore prediction equal to model x train tensor, right? Similarly accuracy equal to y underscore prediction equal to y train tensor. It is a standard fixed here, right? So whatever the accuracy is generated, accuracy, look at this, 78%, right? So this is how the accuracy is calculated. After that, apply PCA for visualization. PCA is the function here, PCA. Okay, now here x train PCA and y train x test PCA. So PCA dot fit transform. Again we are going to fit the transformation, right? Fit for transform, right? Then let me do this. Now if I paste this, now see here, plot decision boundary. This is the function, or we can say the definition, in which model x PCA and the y value are taken out. Now what happened here, x min, x minimum, x maximum, right? Similarly y minimum, y maximum. So these are the complete predefined function here, right? Now what we need to do is, now look at this. This is how it has divided the data. It has divided the data into very into 2D part, right? Since that is our row data and the column data, the data that consists of row and column, but here it has converted into 2D data, and the whole all the values are converted between minus to plus, right? So this is how the data is divided into 2D array, right? 2D picture. Now the final step is, now we are taking, now everything is done, we have taken on historical data. So far we were doing everything in historical data. Now in this historical data we reach up to this level that we could be able to showcase the image, showcase the data in this following image, right? Now how do we know that we have splitted the data, everything goes correctly? Because yeah, we need to have some dummy data. Now what we are going to do, that we are going to have some data here. So look at this. This is a new data of one candidate, right? This is a new data of one candidate. For example, this 58 is written here. That is the age, and the gender, just a second, gender is male. So in this way we are feeding one single entry data, single row data, right? After that, with torch.no gradient, and we are creating the data, that means it is creating the data by default, and state and left. Now suppose if I enter this, now see here how we got what we get here. New data point are this, predicted class, that is 0, attrition is left. That means this person will also switch to another company, right? So this is how the calculation is done. Okay, we are just applying the rules, we are just taking the formulas and applying it wherever it is required, right? So let's have a quick recap here again, exactly what we were doing. See, we are doing just perceptron is much better than single layer perceptron, because in multi-layer perceptron the decision making, right, different neurals. Suppose if one thing is not checked at this point, so it will be rectified on the another point, right? Okay, so let's have a quick recap. First of all, the torch library is called here, then torch.nn as nn, torch.optim as optim, that is the another one torch library, then numpy as np for plotting the data, right, sklearn, and then the import pandas, right? So last is import pandas. Now see here, first of all we will run all these libraries, right? Then we will see here data equal to, then the data equal to first we read the data, it comes here, then what we have done, we have converted the numerical alphabetical value into the numerical data, right, not variable. After that it looked something like this. Then again now we have to, what we need to do, we need to separate the data into x and y, that means the dependent variable data and the independent variable data, right? After that you see here the array is created x, then the shape is taken here, right? Now the shape, look at this, x shape and y shape, it gives you the number of columns, right? After that scalar, now see here so we have to put the data into x turn and y turn, because now convert to Pytorch tensor. First of all we need to convert it into Pytorch. So how to convert that into the Pytorch? With the help of this formula, right? X train tensor, y train tensor, x test tensor, y test tensor, right? So these are the torch.tensor, and x train, all the 4 variables are written here. Now what happens here, suppose if I go again a little bit down, now see here, define MLP model, that is the multi-layer perceptron model, right? So now this is the fix, right? Again same thing here, if you see here, model loss and optimizer, right? After that model equal to MLP, whatever the input module, whatever the input dimension, output size, all these, right, we have written here. After that we see here running the epochs means the repetition, so these things are used here, right? Then in this epochs, after that evaluate the model in train data. So first of all we need to have the train data, then only we can be able to put that data y prediction into the train data. After that here you see the 78% accuracy is given, right? That means 78% accurate for our data. After that if you see here, apply PCA for visualization. So PC is a function that is used by the right, so that PC is a function that is used, right? So xtrain and xtest, we need to get the data, and then so xtrain PCA, xtest PCA, that means PCA dot fit transform, and then xtest x test PCA equal to PCA dot transform x test. Okay, now after that, after applying the PCA visualization, and then PC equal to, this is what we have done. Yeah, this is, so plot decision boundary. Plot decision boundary means whatever the decision is taken, so based on that it divides the complete data of columns into this 2D image, right? And in this 2D image we have we are able to see this whatever the trend is going on, right? And then what we need to do, we need one for whether our mechanism is working. So what we need to do, new data, we are taking the new data and then new data scaled, we are scaling the new data, and then immediately this transform and tensor formula is executed, and then we with the torch dot no gradient, right? So here already we have written here new data, and the if, now here we are applying the for loop, right? So if int new prediction class dot item equal to 1, then print of attrition stayed, attrition left. So based on this we are now extracting the data, which is much more accurate. So in this way multi-layer perceptron is used. Okay, so now tomorrow session, right, on Monday, no not Monday, on tomorrow only we will see different usage of perceptron, right? In which condition the perceptron is used, whether a single perceptron or the multi-layer perceptron, right? So guys, I recommend you again, because these videos are very what we say, very important videos. I suggest you to watch it twice, thrice, then the things becomes clear to you, and if another thing any other doubt is there, you can easily put it in the current comment box, and then I will reply. So guys, those who are new, please subscribe the channel so that you will get the notification, and then in our tomorrow session we will see some other new topics, right? So thank you guys, thanks for